Welcome to example number 2 for word problems involving sine law, cosine law, and or primary trig ratios. We have a situation here with Brenda and Leanna. Let me upgrade the size of this font here. Okay, Brenda and Leanna are standing on opposite sides of a metropolitan tower. Brenda's angle of elevation to the top of the metropolitan tower is 65 degrees, and Leanna's angle of elevation is 43 degrees. If they are standing 37.4 meters apart from each other, what is the height of the metropolitan tower? So we have to understand what's going on here. I'm going to have to break this down. We have Brenda and Leanna standing on opposite sides of a tower. I'm going to draw my tower like that. It's a metropolitan tower, so I'm going to write M there. And Brenda and Leanna are on opposite sides of this tower. So here we have Brenda, and then we have Leanna. Now, they are 37.4 meters apart from each other. So I'm going to, that part, I'm going to put 37.4 meters here. Now, there's a very important question. It says Brenda's angle of elevation to the top of the tower is 65 degrees, and Leanna's is 43. So the way I've drawn it here is that they're both equal distance from the tower, just on opposite ends. But that doesn't make sense given the fact that one is looking all the way up at 65 degrees, looking up like that, and one is just like kind of tilting her head upwards. So the question you got to ask yourself is, which one's closer? Is the person who's tilting their head up higher, closer to the tower, or is the one who's tilting their head up just a little bit closer? And the answer is that this right here is a bigger angle. They're going to be closer because they have to tilt, in order to see the tower, they have to tilt their head up way higher, right? So that's the angle of elevation. So what I'm going to do is I'm going to get this, erase it a little bit, not just a little bit, but all of it, I guess, and have Brenda be a little bit closer. So remember, this is the key term. It says angle of elevation. Angle of elevation, you gotta draw horizontal, and then you tilt up 65 degrees. So that's a huge tilt of the head in order to see the tower. Whereas Linda, I'm gonna exaggerate this, exaggerate this a little bit more close, farther. Get my eraser here. She only has to tilt, so from the horizontal, she's gonna only have to tilt it 40 degrees, or 43 degrees? Yeah, 43 degrees, in order to see the top of the tower. Okay, so make sure you understand the concept of which one's closer and farther. Now, this 37.4 meters is this distance here. Okay, so they want to know the height of this tower. So I'm going to call that H. Hello. And this is what we're looking for. Okay, so what we have is triangle BLM. That is what I see right now. So triangle BLM, we have angle, side, angle. And that is not side, side, side. It is not side, angle, side. And as a result, we know we have an angle side pairing, or we have a potential angle side pairing, which will help us use sine law. Okay, so we want to use sine law, but there's no angle side pairing. Like there's this angle here, there's no associated side here. We don't know that side. We have this angle here, but across from it, we do not have that side. And over here, we have this side, but we don't have that angle. But we can find that angle quite easily. This one right here, maybe I'm going to put this in red. We can find it because we know this triangle BLM is adds up to 180. So we're going to take 180, subtract 65, subtract 43, and that's 108, so that's 72. Yeah, 72 degrees. So now we have an angle and side pairing, which are opposite from one another. So now we can actually use sine law. So we're going to use, we're going to solve for, we need to solve for, I guess, one of these sides here. So we can solve for, I don't know, this one. So B over sine B, L over sine L, and M over sine M. And so we can plug in what we know. So we do not know side B, but we do know angle B, which is sine of 65. L, which is small l, which is that side, which is what we do not know. And big L, which is 43. And M, we know is 37.4. And this will be sine of big M, which is 72. Now we're going to have to choose this one because we know this one has all the numbers. We have to choose two of the three here. So we definitely choose this one because it has all the numbers, and let's choose this one because it has one unknown, and we can solve for L there. It actually doesn't matter, you can solve for B or L, and you'll still get the same answer. So I'm just going to choose L, and here we go. How do we solve for L in this situation? Actually, we don't have to write it out like that. In order to isolate for L, we need to do the opposite dividing by sine 43. The opposite of dividing by sine 43 is multiplying by sine 43. So 37.4 times sine 43 over sine 72. Okay, now we're going to plug this into our calculator, which is 37.4. I don't know why I wrote that 1 there. So 37.4 times sine 43 divided by sine 72. And that is 26.8 ... 26.8, a whole bunch of numbers. That is little l, which is 26.8. Whoa, 26.8 ... And we know that this is a tower, right? We want to find the height of it, and because we can assume when we're measuring the height of something it's going to be 90 degrees with the ground, we can work with triangle MBA. Okay, so we know it's 9 degrees, and as a result, if we know it's 9 degrees, we can use the primary trig ratios, which is so katoa. Alright, and now we have to label our focus angle, which is going to be this one, and start labeling the sides appropriately. So across from my focus angle is the opposite. Across from the 90-degree symbol is the hypotenuse, and the last one's going to be my adjacent. And again, because I want to know what the height of this tower is, we're going to need the opposite. And we also have the hypotenuse. So we are going to use sine. So let's write out sine of angle B. It's opposite over hypotenuse. And angle B is 65. We're going to plug in what we know. Opposite we do not know. I'm going to call that H. And the hypotenuse is 26.81 ... And again, to isolate for H, we do the opposite of dividing by 26.81. We multiply both sides by 26.81. 26.81 ... all those decimals. Okay, I'm going to write it over here. And then run out of space. Oopsies. Okay, so H is going to be 24.306 ... and because there is one decimal place here, I can round it to one decimal place, so 24.3, and I'm going to write approximately here. And we're going to finish this off with a therefore statement because this is a word problem. If they start in words, we're going to end in words. What does this 24.3 mean in the context of the situation? So it's the height. The height of the Metropolitan Tower, of the Metro Tower, is 24.3 meters approximately, because we rounded. And as a result, because it's rounded, we are done. Okay, so let's recap here. We were given a word problem. We had to translate that word problem into a diagram to make sense of what was going on. once we had that diagram, we identified what we were given. In this case, in triangle BLM, we were given angle side angle. Given angle side angle means we have to use sine law because we only use cosine law for these two. So I eliminated cosine law, meaning we have to use sine law. But even then, we didn't have an angle side pairing here. We had to do some extra work right here in order to figure out what that angle was. And now that we have, then and only then did we have an angle side pairing. And once we have an angle side pairing, we can solve for anything in the sine law, any unknown there. So we decided to solve for L, and you could have solved for B. It doesn't matter. You can work with this triangle if you wanted to. But I chose L. I studied for L. Then once you have L, you identify that you can work with this triangle now. And this is a triangle that we're actually kind of interested in because it's the triangle that involves what they're interested in. They're looking for the height. This is the triangle that has the height. So we looked at this triangle, identified that it was a 90-degree triangle, used the primary trig ratios. We identified the opposite hypotenuse and adjacent, and then we plugged in what we knew, solved for h, and therefore statement. Okay, and so that finishes off this example. If there's any questions, please email me or Google chat me, and then we'll see you on the next video.